Okay, so now we've got the mirrors aligned and the laser itself. So what I want to do now is find out where the focal point is on the laser. Now there's a 2-inch lens in there which is 50.8 millimeters. Now, so 50.8 millimeters. The lens, the bottom of the lens is about a millimeter or so, about 2 millimeters actually up in there. So from the underside of that to the actual bed, that is approximately the right distance to be perfectly focused. But I want to check to see what the focal distance is. In other words, the workable distance of the focused beam. Okay, so we've got Inkscape open now, so what I'm going to do is I'm just going to choose a line. I'm going to start here at the 50 and go to 150, thereabouts. It's just roughly. And then I'm going to come here to stroke paint. I'm going to cut out of it. This just represents red, green and blue. So we want to cut, so we want it 100% red. And we're going to go to stroke style and we're going to raise this up to about a millimeter. Like that. And now we can see it. It looks just fine. There it is. So now we've got that as a red line, about 100 millimeters long. We're going to go over here to File, Document Properties. Ensure that millimeters are selected, and we're going to make it a bit smaller because this is A4 size at the moment. It's just going to take up too much memory, so I'm going to bring it down to something. Let's go landscape first off, and then bring it down to something quite small. Something like this one here. I think that'll do. And we're going to position this in our piece of work. It's somewhere in here you can actually reduce it to the size of the actual object. But this is okay for what I want to do at the moment. So there it is in that little box. I'm happy with that. So we're going to go up here to File and then Save As, and we're going to save it to PC, Desktop, and we're going to name this Test 1, which it is. Inkscape SVG file and save. So now we're going to start K40 Whisperer, which is up. I'm going to start the laser and initialize the laser. Initialize the laser, then open the file, desktop, where is it? There it is, there, test 1, open. And there it is. Probably could have been a bit straighter, but it's okay. So now I'm going to bring the camera down to the inside of the laser, and I'm going to show you what we're going to do. Okay, so I'm just going to lift this out to reveal the clamp. Now, what I'm going to do, because I need to find out where the focal length is, or what the focal length is, and that is the area in distance from the underside of the lens that is usable. So what I'm going to do is open this, for want of a better word, clamp. This is just a piece of hardboard that's white on one side. Put it in an angle and just make, sort of clamp it there. That's the this is the best purpose I've found for this clamp so far. So then what I'm going to do is jog this over, and I want to start about this area, and we're going to run that line, which is 100 millimeters long, from here up, and we're going to find the narrowest part of the beam cut in this white material. Let me just get my ruler. Now I'm just going to jog this over a bit. A lot. I just want to measure 100. We can come over that way a little bit. So it's going to start about here and come to about and finish about there. And I think I'll take it back that way a little bit because I'll do a couple of runs. I think that'll be alright. I want to get a couple of runs out of this. So I'm going to select, let me see. I've just turned the selector up to about 10 milliamps. Actually, I might take it to about 12. I don't want to actually cut through this. I'm just after a line. So let's see. Let's run this. I'll zoom you in a bit. So here we go. I'm running at 10 millimeters per second. Let's see what happens. You can see the rooster tail there. Yeah, I'm just going to move 10 millimeters. Oh, let me have a look. Let's examine that, shall we? Let's have a look. Okay, so looking at that, the usable length is from about there to about there. Although it's very, very fine, you know. I'm going to run that again. Not so much power. I want a bit of a more defined line there. Okay, not so much power this time. Let's try it again. Got a good old rooster tail going there. I think we can cut the power back even further actually. I'm just going to raise the speed up a little. I'll leave it the same power setting, which is about 10 milliamps. So I'm going to raise up now to about 15 millimeters per second, and we're going to cut again. Here we go. I'm going to come over again. I'm going to raise the speed up even further. This is now 20 seconds per... This is now 20 millimeters per second. Here we go again. And I'm going to do it again over another 10 millimeters over this way. And I'm going to do, I'm going to go 30 millimeters per second. Here we go. Cut in now. Okay. It actually works out that our working focal point then is actually the surface of this material. And really the focal depth then, usable depth, is from the top of the bed about, let me see, not very far. It's actually about 3 millimeters above, which is about 1/8 of an inch, and about 3 millimeters below. So the total focal distance, the usable distance, is about 6 millimeters. So it's 3 millimeter above the height of this bed and 3 millimeters below. That's a very useful thing to know. So they've actually got this clamping mechanism in the optimum point, I suppose. Okay, so, well, let's cut something out, I suppose. Okay, so what I've done is I've just drawn a simple 2-inch square, and I'm going to pop this piece of just a 1/8 inch plyboard in here. Ooh, I don't know how to get it in here without pinching me. Oh, that bites. Okay, I've got that piece of material now just there, so I'm going to position the head somewhere here. I'm just going to do a test a little bit further over this way, I think. Okay, so we know where it is. So I'm going to zoom the camera in a little bit to that localized area. So what I'm looking for here is how it cuts and how much flame, smoke and debris actually comes off the material and how good this extraction unit is actually working. So I'm going to give it... Okay, so I've turned it up to approximately 15 milliamps. I'm going to set the cut speed at about 8 millimeters per second just to try it. And I'm looking for a clean cut. I'm looking for it to fall out. Well, we'll see what happens. So I'm going to initiate the cut now. A lot of smoke coming up, a little bit going out at the bottom. Got a bit of flame. Of course, the flame is the debris, smoke ignited. This is not a good thing to have flame like this. Well, it cut it out. Well, that astonishes me. It just cut it out without thinking about it. I'm going to up the speed a bit. Okay, so let's run this now. It's set at 12 millimeters per second. Yeah, a lot of smoke coming up, but it cut it out. Not bad at all. Let's go to 14 millimeters per second now. Okay, so the result was, and what we're looking for is the cleanest cut we can get for the power and speed. So this was the first one at 10 millimeters per second at 15 milliamps. A little bit of muck on the underside, not much. This is the underside, by the way, but it cleanly cut it through, but the material's quite dark. So 12 millimeters per second. Not much difference between them, except they cut a little bit quicker. But 14, you'll find now we're starting to get quite a bit lighter. Now this is what you're after. Now you see a lot of people using these laser cutting machines, and this is all burnt, charred black. That is not the way to do it. The way to do it is to use the power and speed in such a way that it leaves you a nice clean cut. That is a nice clean cut. I dare say it might go to 15 millimeters per second, and I dare say it would cut slightly thicker material too. That's 1/8 inch pine. That is 1/8 inch of let's see, 3-ply, something like that. Softwood ply, but it did a very, very good job. So what have we learnt today? Well, what I've learnt is, straight out of the box, my particular machine, my 40-watt laser, basically didn't work because the laser tube itself was not in the correct orientation. So I reorientated the laser. I've adjusted all the mirrors up now, so they're all as perfect as I can get them. and in line. And we've just done our first test cut. And I don't mind telling you, once you've got it right, once you've got everything in line, it does a pretty damn good job. I'm surprised. I'm really surprised. That last cut is a nice cut. I wasn't expecting it to actually perform as nice as that, but it is. However, excuse the parrots, by the way, as they're feeding time out there, I think. However, we can do an awful lot better with this machine. We can make it perform a lot better. And over the last few days, I've been receiving things that I have purchased from eBay and Amazon, which is, both fairly good resources for, shall we say, parts to upgrade this. So I'll just fetch a couple now. So the first thing we're going to do is replace that nozzle with this. Now this one is an air assist nozzle. Very important actually, because what the air assist does, it not only, should we say, blows the debris out of the cut and stops it bursting into flames. Another reason for having this is to stop you destroying your lens, because what it actually does is it blows air in underneath the lens, it circulates and then comes out. It keeps the lens cool and it keeps it clean. So that is a must. And of course, alongside this, you need one of these. This is a little impulse compressor. It's only a very small one. I'm not sure how many litres per minute. 40. No, what am I talking about? About 60 litres per minute of air under pressure, which is enough for this little machine. And then the next thing we're going to do is improve the airflow. Okay, they've gone part way there by replacing that big horrible square box affair fan they used to use on the back. This one that's been fitted now is a lot better and it's quite powerful, but it's still not powerful enough. So we're going to fit one of these. That's not a jet engine. Although it operates like one. You've got a fan, you've got an intake fan there and another fan in there, and yeah, this will push air. So what I'm going to do is I'm going to run the two of these fans, together. In other words, use that fan in this unit and then use this one in the line, which will really move some air, which is what you're after. And I'm actually going to cut this back to reveal, well, it's acting like a choke, and it's choking the airflow up. It is better. They have improved it, but I think we can improve it even more. So the next video is going to consist of doing some of these upgrades to make this a really useful little tool in my workshop. So, if you've liked this video, please like and subscribe. And if you would like to consider becoming a patron to the channel, because it's the patrons behind this channel that keeps it going. Without the patrons, I probably could not do what I do. So please consider that. And come and have a look at one of my other videos on, well, the list is getting quite big now because there's nearly 600 videos. CNC routing, CNC milling, CNC lathe, big 100 watt laser, now this one, wood turning, oh, the list goes on. So thank you for joining me, and I'll see you next time. Bye now.